So yesterday was exponentials. Exponentials are useful for interest, for population growth, disease vectors, anything that grows very quickly. So like if one person's sick and they infect 2 people and they infect 2 people and they infect 2 people, everybody's infected in a hurry.
National debt.
Yeah, national debt. Logarithms, this is logarithms we're talking about now. Logarithms are the inverse. Of exponentials. As in everything in algebra, you have to be able to undo what you do. These are the undoers. All right, squares, square roots, exponentials, logarithms. They're all undoing each other. You read this as y equals log base b of x. There's a couple special ones out here. B can be any number. Log base 2, log base 3. So for instance, if I have 3 to the x, the opposite of that is log base 3. That's the inverse of it. Okay, if I have 5 to the x, the inverse of that is log base 5. We have 2 that have no base on them, but there's a base implied. Natural log is log base e. So if I have e to the x, its inverse is natural log. And log with no number on it, so if you look at your calculator right here, see this log with no number on it, right there? That is log base 10. So 10 to the x, its inverse is log with no number, otherwise known as log base 10. Your calculator only has log base 10 and natural log on it. All the rest of them, you have to get through this way. If you will press alpha window, number 5 right there is log base any other number you're interested in. Okay? And we'll get to that stuff later. I just wanted to show you where it's at in your calculator. We have some properties of logarithms. If I am multiplying 2 things together inside of a set of parentheses, log base something of 2 times 3, for instance, would be equivalent to log base something of 2 plus log base something of 3. We're going to use these to reorganize equations to solve. Flop back and forth between these different forms. Log base b of m divided by n can be rewritten as log base b of m minus log base b of n. So let me show you an example here. If I have log of 2 times 3, that's the same as log of 2 plus log of 3. And log of 2 divided by 3 would equal to log of 2 minus log of 3. Kind of weird rules. And the final one right here is log base b of m to some power n. You can bring the exponent down as a coefficient and vice versa. So if I had, for instance, log of 2 cubed, that would be equivalent to 3 times the log of 2. Those are equivalent statements. All right? Weird, but very, very important to know these things. They're going to use them a bunch as we're solving equations. So if you're asked to solve for x, you need to recognize that you need the inverse of whatever you're looking at. So if I have log base b of b to the x, these guys right here are going to cancel each other. Log base b of b. That's an inverse. That's like saying square root of x squared. So those are going to cancel, and the x is going to be all you have left. If I have b to the log base b, again, those are going to cancel. Let's write 2 examples. Well, I've got some examples down here like that in a second. Natural log and e are going to cancel. So these guys cancel, and the x is what's left. These guys cancel, and the x is what's left. Natural log and e are going to cancel, and the x will be what's left. And the e and the natural log will cancel. These are all different examples of reciprocal operations here. So I want to solve this one for x right here. What is the inverse of log base 5? It would be 5 to the power of. Okay, 5 is the base of an exponent. So the inverse of log base 5 is 5 as the base of an exponent. And what happens right here? These guys are going to do what? They're going to cancel. And so x is going to be equal to 5 to the y power. If you wanted a number right there, when does 2 equal to log base 5? What value of x would make this true? Well, take both things to the 5 power, right? X is going to be equal to 25. That's the same example with numbers in it, okay? Alright. Same thing here if I want to solve for x. What is the inverse of exponent base 2? Not natural log, but log base 2. Log base 2. Log base 2 of y. And log base 2. I don't have room to write this, but log base 2 of 2 to the x. And log base 2 into the 2 we're going to do what? We're going to cancel. So x is going to be equal to log base 2 of y. If you wanted an example with numbers, 8 equals to 2 to the x. You should know the answer to this already. What is x going to be? Try again. 3. There we go. Yep. There we go. All right. 2 to the 4 is 16. 2 cubed is 3. Right. Let's see if we get that answer. Okay. How do I undo 2 to the power of x? I take the log base 2. Log base 2 of both sides. Log base 2 of 2 to the x. The 2 is canceled, so I have x equal to log base 2 of 8. Type in your calculator. Alpha window. Log base 2 of 8. And we get 3. Okay. All right. 5 equals natural log of x. What is the inverse of that? How to get x by itself? Inverse of natural log is e, right? E. So in this case, not e to the x, but e to the 5. And e the natural log. Those are going to cancel. And finally, log of x squared equal to 6. So what was our property on logs raised to an exponent? Comes the coefficient, right? You have to bring it down, make it the coefficient. Divide both sides by 2. What is the inverse of log with no number? 10. So x equals to 10 cubed, or equals to 1,000. And that's it.
And if you divide a log by 2, you get a plane.
You get actually a log divided by 2. You get a seat, right? Okay. Started.
I also think you didn't post the homework.
Yeah, I have.
Is the homework on the classroom that says like 10:25? That was when we were doing our review, right?
Let me go see. Are you missing one?
Yeah. What it says on the classroom.
It says, yeah, but on